Rare earth elements are a group of 17 metallic elements. They aren't actually rare, but they're difficult to mine and process. These elements possess unique magnetic and conductive properties. These properties make them essential for modern technology. Smartphones, computers, and electric vehicles all rely on rare earth elements. They are also crucial for defense systems, including missiles and radar. Without rare earths, many technologies would be impossible to manufacture. This makes securing a stable supply of these elements a top priority for many countries, especially the United States. China has a firm grip on the global rare earth market. Rare earth elements, a group of 17 metals, are crucial for the production of high-tech devices, renewable energy technologies, and military applications. These elements are used in everything from smartphones and electric vehicles to advanced weaponry and satellites. For decades, China has invested heavily in rare earth mining and processing. The country recognized early on the strategic importance of these materials and has built a robust infrastructure to support their extraction and refinement. This includes state-of-the-art processing plants and advanced mining technologies. As a result, it now controls the majority of global production. China's dominance in this sector is not just a matter of having large reserves, it also stems from its ability to process these elements efficiently and at a lower cost than other countries. This dominance gives China significant leverage. By controlling the supply chain of these critical materials, China can exert influence over global markets and geopolitical dynamics. This control extends beyond economics, impacting international relations and strategic alliances. By controlling supply, China can influence global prices for these critical materials. Fluctuations in rare earth prices can have a ripple effect on various industries, from consumer electronics to defense. This economic power allows China to negotiate from a position of strength in international trade deals. This situation has raised concerns about potential economic and political vulnerabilities for other countries dependent on Chinese exports. Nations that rely heavily on Chinese rare earths find themselves in a precarious position, vulnerable to supply disruptions and price manipulations. The US and other nations are acutely aware of this dependence. Governments and industries are increasingly recognizing the need to secure alternative sources of rare earth elements to mitigate the risks associated with over-reliance on a single supplier. They are actively seeking ways to diversify their sources of rare earth elements and reduce their reliance on China. This includes investing in domestic mining operations, exploring new deposits in other countries, and developing recycling technologies to reclaim rare earths from used products. The goal is to create a more resilient and secure supply chain for these indispensable materials. The possibility of China restricting rare earth exports is a serious concern for the US. Such a move would have significant consequences for American industries. In a worst-case scenario, an export ban could disrupt supply chains and cripple manufacturing. This vulnerability has fueled a sense of urgency in the US to find alternative sources of rare earths. The US is exploring several options to reduce its reliance on Chinese rare earths. These options include boosting domestic production, finding new international suppliers, and investing in recycling technologies. The Pacific Ocean floor presents a potentially vast, untapped source of rare earth elements. Scientists have discovered rich deposits of these minerals scattered across the seabed. These underwater deposits, known as polymetallic nodules, offer a potential lifeline for countries seeking to secure their rare earth supplies. However, accessing these underwater treasures presents significant technological and environmental challenges. Section 5. Underwater robots, the technology of extraction. In this section, we delve into the fascinating world of underwater robots and their pivotal role in the extraction of valuable resources from the ocean floor. Extracting rare earths from the ocean floor requires advanced technology. The ocean floor is a treasure trove of minerals, but accessing these resources is no small feat. It demands cutting-edge equipment and innovative techniques to navigate the challenging underwater environment. Remotely operated vehicles, or ROVs, would play a crucial role in this endeavor. These sophisticated machines are designed to be the eyes and hands of scientists and engineers, allowing them to explore and interact with the deep-sea environment without ever leaving the surface. These underwater robots can operate at extreme depths and withstand the harsh ocean environment. The deep sea is a place of immense pressure, frigid temperatures, and complete darkness. Yet ROVs are built to endure these conditions, making them indispensable tools for deep-sea exploration and extraction. Equipped with specialized tools, ROVs could collect the mineral-rich nodules from the seabed. These nodules contain a variety of valuable elements, including rare earth metals that are essential for modern technology. The precision and dexterity of ROVs make them ideal for this delicate task. Developing and deploying this technology on a large scale requires significant investment. The costs associated with designing, building, and maintaining ROVs, as well as the infrastructure needed to support deep-sea mining operations, are substantial. However, the potential rewards make it a worthwhile endeavor. Companies at the forefront of deep-sea mining are actively researching and refining these technologies to make extraction efficient and commercially viable. These efforts include improving the capabilities of ROVs, developing new methods for processing extracted materials, and ensuring that mining activities are conducted in an environmentally responsible manner. The future of deep-sea mining holds great promise, and the technology of extraction will continue to evolve, opening up new possibilities for resource acquisition from the depths of our oceans. Section 6. Environmental concerns, protecting marine ecosystems. Deep-sea mining raises significant environmental concerns. The seabed is a delicate ecosystem, home to a diverse array of marine life. Mining operations could disturb these ecosystems, potentially harming marine life and disrupting the ecological balance. Scientists and environmental groups are urging caution. They emphasize the need for comprehensive environmental impact assessments before large-scale mining operations commence. Section 7. International Law, Navigating the High Seas. Mining in international waters falls under the jurisdiction of the International Seabed Authority, or ISA. This UN-affiliated body is responsible for regulating deep-sea mining activities. The ISA is currently developing a legal framework to govern deep-sea mining. This framework aims to balance economic interests with environmental protection. Establishing clear guidelines and regulations is crucial to ensure responsible and sustainable mining practices in the deep sea. Section 8. Economic Viability, Costs and Benefits Analysis. The economic viability of deep-sea mining is a complex equation. Factors to consider include the market price of rare earths, the cost of technology, and the potential environmental remediation expenses. Proponents argue that deep-sea mining could provide a significant return on investment, while also reducing dependence on China. However, critics contend that the environmental costs and technological hurdles could make this venture economically unsustainable in the long run. Section 9. The Future of Mining, a Deep-Sea Revolution. As we stand on the brink of a new era in resource extraction, the depths of our oceans present both an opportunity and a challenge. The concept of deep-sea mining is not just a futuristic fantasy, it is rapidly becoming a reality. Deep-sea mining holds both promise and peril. On one hand, it offers access to vast reserves of minerals and rare earth elements that are essential for modern technology. These resources are critical for the production of everything from smartphones to electric vehicles. It offers a potential solution to the geopolitical challenges of rare earth dependence, reducing the stranglehold that certain nations have on these vital materials. By tapping into the ocean's bounty, we could diversify our supply chains and enhance global trade stability. But it also poses significant risks to the marine environment. The ocean is a delicate ecosystem, home to countless species that could be disrupted or even destroyed by mining activities. The potential for environmental damage is immense, from the destruction of coral reefs to the pollution of underwater habitats. The international community faces a crucial decision. Policymakers, scientists, and industry leaders must come together to establish regulations that protect our oceans while allowing for responsible resource extraction. This is a global issue that requires a coordinated effort. Striking a balance between resource security and environmental protection will be paramount as we venture into the uncharted territory of deep-sea mining. Comprehensive environmental impact studies and ongoing research are essential to understand the full implications of these activities. The future of mining may lie in the depths of the ocean, but it is a future that must be approached with caution. Advanced technologies and innovative methods will be required to minimize the environmental footprint of mining operations. Navigating this new frontier demands careful consideration, technological innovation, and a commitment to sustainable practices. Engineers and scientists are already developing cutting-edge solutions, such as autonomous underwater robots and eco-friendly mining techniques, and a steadfast commitment to sustainability. The integration of renewable energy sources and sustainable mining practices will be crucial in ensuring that deep-sea mining does not come at the expense of our planet's health. As we explore this new frontier, we must do so with a vision of harmony between progress and preservation.